Okay guys, let's continue solving our task, and the next task would be the following. So the task called the minimum number of pushes to type word 2. So you're given a string word, right, containing lowercase English letters, and telephone keypads have keys mapped with a distinct collection of lowercase English letter, which can be used to form words by pushing them. For example, the key 2 is mapped to ABC, and we need to push the key 1 time to type A, 2 times B, and 3 times C. It's allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. Okay. You need to find the minimum number of times the keys will be pushed to type the string word. Return the minimum number of pushes needed to type word after remapping the keys. An example mapping of letters to keys on telephone keypad is given below. 1 star slash 0 do not map to any letters. Okay. And yeah, so we have different keypads, and we have, for example, A, B, C, D, A, right? So we see that like 5 times we press on each key and we receive 5. Okay. And as well here, we see X 2 times, 1 push on X, and multiply by 4, then Y multiply by 4, and so on. So we have to return the minimum number of pushes needed to type word. Okay, so we have some words, right? And this word can be 100,000 letters. All right, and we have kind of 6, 7, 8 numbers that would be used as our keypad. So how can we actually solve this problem? So I suggest that we can go through our word and create for each character's number of elements, how much of elements it has, right? So we have, for example, C, A, Q 1 time, and A, for example, 3 times, right? So we have kind of adjacency list. And what can we do next? Next, I think that we can do the following. If it's even only lowercase English letters, we can create like an array, maybe, yeah, and then we can like map all our elements here. But we what we need to do, so it's the same like map actually. What do we need to do? Then we need to create kind of a heap, where in heap we will put an element and we check by count of numbers. And then we will take from the heap each of our key. Yeah. And and we will calculate how numbers of values we will have. So we should not have more than 8 on the third power. Uh, 26, right? So we don't need to have it. So for each of these numbers, we will have for 1. Then yes, and for the next values, when it would be 8, then we will have 2 and so on. So the logic would be the following, and time complexity would be here the heap, creation of heap, it's n log n. And that's it. And for storing all these elements as a space complexity. So let's have our int result. Then let's create our array, 26 elements. Okay, and let's go for each character in our word and put it in array. Let's create a heap. Let's populate our heap. Let's populate our heap. I think we can create heap, or we can even, I think, sort our array, right? And it will sort descendingly, so we can go from the end. It would be int I equal to array length -1, I is greater or equal 0, I minus minus. And here we have our counter that would be 0, and we will check if our counter equals to 8. We would have also our, let's say, weight, it is 1, and here weight will be increased, and counter equal to 0. And here it should be else. Also, we should do it for all elements when it's not equal to 0. Okay. Here will be return result. Here should be counter plus plus and result weight multiply by array I. Okay. I think that's, and here I think here it should be always like this. Let's go. To char array. Arrays. Submit. All right. it wrong answer. Why it's wrong answer? Let's check. So we have 1. So I believe that all this we don't have the same values here, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and 1. So here we should have 8, right? Is 7. Not sure. Let's check. Yeah, maybe here 1. Here 8. I think this one. Yeah. Submit. Okay, so now it's accepted. And let's check editorial and solutions. Okay, so we are checking frequency. Yeah, and sort. And then answer. Okay, so the same logic here. Same logic. Yeah, so that's it. Thank you, and see you next time.